Hey guys, Nick Phelps here, consulting architect with Logix1 here on JourneyToTheCloud.com with the second of five Cisco Live 2013 videos. Basically doing one of these at the end of each day to kind of highlight some of the technologies that I got to explore, whether it be in breakout sessions or on the trade show floor, and hopefully bringing back some usable information on some of the things that we're capturing here, hoping to be able to encapsulate within our features and offerings to our client base to bring some more value with some new technology. So right now, basically, I spent my time today going through a series of breakout sessions, technical tutorials, or just technical breakout sessions in general. So I had some really good ones, and you're going to hear a lot from me this whole trip about SDN and a lot about SDN. And so, well, one thing I guess it's important to understand is that there's really not one or any one even group of sessions that kind of define very well exactly what Cisco is trying to get at with SDN. I think the picture I have is starting to become clear as I kind of roll through this. So we spent some time first thing this morning on some overlay technology, dealing specifically with OTV. Really good session. They talked about basically some of the new features that are coming out in the new releases of NXOS as it relates to OTV, basically doubling the capacity of a lot of this stuff. Whereas you have 6 sites supported now, they're going to 10. They have 256 OTV extended VLANs right now. That's going to 1,500. They have 16,000 MAC addresses available right now across all the extended VLANs. That's going up to 32,000. And the multicast data groups is going from 2,000 to 4,000. So anywhere between 100 and a 580% increase in some of their base feature sets as it has to do with OTV, which is very, very cool. Some of these limitations people have been griping about for quite a while, at least what I've heard in the client base. It's been some pretty restrictive limitations that people have been really excited to get rid of. So those are coming. We also talked a little bit about some of the features that are coming out, just general with Nexus and NXOS as it plays into version 6.2 and as it relates to the F3 series line cards that are coming out, being announced tomorrow actually at a keynote, and they're coming out later this year. The main distinction is right now F2 and F2E line cards can't be mixed with M series line cards right now in one BDC. We've had this problem come up with a number of clients where they wanted the connectivity and some of the feature sets of some F series or F2 series cards and some M series cards, usually from a connectivity and density perspective, and you haven't been able to mix those traditionally inside of a BDC. The F3 line cards that are coming out are going to enable you to do that. You're going to be able to take F3 line cards, combine them with F2s, and you'll be able to take F3 line cards and combine them with M series cards. The one distinction that you should note is that you're not going to be able to have, obviously, F3, F2, and M series cards because of the incompatibility between M series and F2 series. So F3 and F2 or F3 and M series is kind of the way it's going, but nonetheless, big improvement. You'll also be able to have native OTV ports, which is very cool. Right now, the F2 cards only support basically the inside ports from the OTV perspective, and you're going to be able to do a little more from an encapsulation native to OTV perspective with these new line cards that are coming out. If you look at the rest of my day so far, I spent a lot of time in the SDN framework workshop. Again, there's a breakout session, technical breakout, dealt with SDN frameworks basically that are enabling intelligent cloud. And we kind of talked a lot about some of the things I mentioned yesterday. We got a little deeper into business drivers, talking about basically how collaboration, ERP, CRM, IT management are basically the ones that are really pushing the benefits that we're seeing from this adoption, which is basically the speed, the degree of cost, rapid deployment, agility. And then, of course, we had some talks about elastic capacity and how that wasn't really a thing that was available to you in the physical world of traditional networking, and some of the ways that we're expanding on that. And we talked a lot about policy and orchestration. And again, if you didn't see the video I posted yesterday, this all relates back to 1PK, right? So 1PK, again, just to kind of recap, is Cisco's overlying technology, and it's basically their SDN play. And 1PK basically is an SDK that enables an API level access to a new application layer, software abstraction layer that lives on top of iOS devices. Doing it across iOS XR, doing it across iOS. They're going to be doing it, it's on NXOS. They're putting it into the ASA platforms. It's really going across the board. Every product Cisco makes, heard it today once again, is going to have this software abstraction layer that enables OpenPK. And basically what that allows you to do is interact with it once again between C, Java, Python. You can code it into applications, and the whole goal, and again, this picture is becoming clearer and clearer to me now, right? It's basically looking like what the overall goal is there's things that, like Cisco Prime, gave you the ability to have application-aware networking, right? But it didn't give you network-aware applications. If you had network-aware applications, they'd be able to give you alerts, and you'd be able to react to those things manually through Prime management and not have to mess with a bunch of different management suites. But now, what I'm really seeing here is that one PK is going to give you this platform to create bidirectional awareness between network and application, right? You're really going to have those pieces to where you can have network-aware applications and application-aware networks. And when those things come together, you're able to have a reactive response to conditions on the network, but it's not manual interaction and reactive activity. It's programmatic reaction. And so I guess what I mean by that is that if you have an application that's network aware, meaning that it knows that there's latency and it's passed to its end users, you're able to actually have that application have a predetermined number of things that it can do to adjust its own latency and performance across the network. So you tell it that, hey, if you see these kinds of latencies and it's going to cause an error condition and a suboptimal user experience, and that's a critical business application, you're going to give that application from a programmatic level the ability to interact with your devices. By the way, side note, 1PK gives the ability to do a lot of things you can do in the command line. You can find out the network topology by jumping through the command line of devices that you see on a trace route, right? So you see a trace route of an ICMP packet. You can go through to each one of those devices and look at CDP, Cisco Discovery Protocol, and pretty well build a pretty accurate network diagram. 1PK has given you the ability to do that very, very seamlessly inside of applications. So an application can look at its path of communication to an endpoint, do that same process, but very much automatically know the topology and have access, if you allow it, to every device along that set of, that path of communication. That being said, if you give it a predetermined things that it can do to that path of communication, like adjusting routes to a more optimal route over a different WAN length to its user base, if you're U-turning traffic, or hairpinning traffic from a hosted application from your office into a data center and back into an office, right? You're able to then be able to let the application influence the path that it takes based on performance. It can change QoS policies. It can change basically anything that you allow it to change that could impact performance. So again, I'll go into what we talked about a little more today, but I kind of just wanted to recap. The picture is really getting clear to me now that it's really, truly becoming a bi-directional platform for application-aware networking and network-aware application programming to be able to make them work together to maintain a user experience. That's the end goal. What they also talked about that became a little more clear today is the XNC, the Extensible Network Controller, which is basically another framework that's basically going to act as, this is a packaged product from Cisco that's not going to be an open development, open source project SDK that you can just grab and program however you want. This is going to be a value add that Cisco's bringing to market that basically is a packaged solution from them to control SDN enabled and SDN compliant devices. And by SDN compliant devices, very generically, I just said that very purposefully, that they're going to support SDN from an OpenFlow perspective, so third-party stuff that runs with OpenFlow. They're also going to be able to support the OpenPK interaction. And then something I made a distinction on yesterday that I thought was the case, and it turns out it's not, is that I thought that basically you're going to use OpenPK to interact with Cisco devices the same way you'd use OpenFlow to interact with non-Cisco devices. Turns out it's not really the case. OpenPK makes use of OpenFlow. So OpenFlow is actually a module that rides and can be used in conjunction with and called on by your OpenPK architecture or your OpenPK programming. So if you wanted to change the flow of a packet and actually adjust the routes, or you're just adjust the anything to do with the control plane functionality of a switch or a router, OpenPK is going to leverage OpenFlow inside of a Cisco device to do that, just like you would leverage OpenFlow directly from a non-Cisco device that doesn't support OpenPK. Now, one thing I will say is I asked one of the guys that was speaking, I said, now, OpenFlow is the standard, right? That's the open source, standard open piece of technology that's driving SDN, or allowing SDN to be driven, I guess I should say. I said, so, OpenPK or 1PK is going to be just Cisco forever, right? That's never going to get mainstream adoption into the open source market, right? He's like, oh, never say never. So I'm thinking that maybe because they're taking this open source kind of collaborative route in developing 1PK, I think maybe there is a chance down the road that it could play very well side by side, agnostically in the market along with OpenFlow. So I think that's a very real possibility.